Welcome back, everyone. Before the break, I defined that a geometric series is when I add the values of a geometric sequence together. The main property of a geometric sequence is the fact that there is a common ratio. In this next lesson, we're going to be doing some more examples using the formula that I derived for a geometric series. Let's have a look at the first example together. So, the question is asking me to determine the sum of the first 8 terms of the geometric series. Please just take note of a few things. If I see the word sum, I know that it is definitely going to be a series. This is not asking me information about Tn, which we use when we are purely working with it in the sequence form. I see the word sum, which means I'm going to be doing a series. I'm determining the sum of the first 8 terms of the geometric series, which has been given to me as 2 minus 12 plus 72. So, we can have a look at this question and we can see that A is 2, because I know that the first term has a value of 2. Now you might be asking why it says negative 12 instead of an addition, because we're working with sum, so we're expecting to see a lot of pluses, but please just remember that 2 plus negative 12 is the same thing as 2 minus 12. So after the negative 12, we can see that 72 has been added. The question is asking me to find the sum of the first 8 terms. So that means for this particular example, n is equal to 8. So in order to substitute this in, I know I've got my n because I'm summing 8 terms, so n is 8. A is equal to 2 as it's the first term. All that I'm missing is r. And how I'm going to calculate r, we know that I can determine r by saying term 2 over term 1, which I can write as negative 12 over 2. So r is equal to 6. Or negative 6 rather, because negative 12 over 2 is negative 6. So the sum of the first 8 terms is going to be equal to 2 times 6 to the power of 8 minus 1 over 6 minus 1. So all I've done now is I've substituted in my A, my R, and my N. Let's get my, The next thing that I need to find is R. And I know that R is equal to T2 over T1, which means that I can substitute in negative 12 for term 2 over 2, and negative 12 over 2 gives me negative 6. So I'm now going to substitute this all into the formula for Sn. So S8, so the sum of the first 8 terms, will be equal to 2 times negative 6, which is my r, to the power of 8 minus 1, all over negative 6 minus 1. Now I'm going to grab my calculator, everyone, because I've got a lot to type in. So I've got 2 multiplied by negative 6 to the power of 8 minus 1, and this is all over minus 6 minus 1. So the sum of the first 8 terms will be equal to negative 479,890. So the sum of the first 8 terms is equal to negative 479,890. Great, so we can see that if we add all of those terms together, it's going to get a really big number as a result of the sum. Let's have a look at the next example together. So this example tells me that the first term of a geometric series is 16, and the sum of the second term and the third term is 12. We now need to determine the sum of the first 10 terms. So I've been given a few different pieces of information that are going to help me answer this question. So the first term of a geometric series is 16. That means that T1 is equal to 16. Then I'm told that the sum of the second and the third term, so the sum of the second and third term I can write as T2 plus T3 is equal to 12. I have various expressions for T, which I'm going to write in terms of A and R. Writing them in terms of A and R will allow me to solve simultaneously, and then I can eventually find the sum of the first 10 terms. Let's go back to the board. So if T1 is equal to 16, I can actually write this as A is equal to 16, because I know that the first term of a geometric sequence is A. Then if I want to write term 2 plus term 3 is equal to 12, I'm going to write AR, because AR is term 2. This is going to be added to term 3, which is AR squared. So AR plus AR squared is equal to 12. This simultaneous equation has been made slightly easier for us because I know what A is from the beginning. I'm going to carry across my A is equal to 16 over to my right-hand side. So I'm going to have 16R plus 16R squared is equal to 12. Great. So now I'm going to make a quadratic equation. So I'm going to have 16R squared minus 16R minus 12 is equal to 0. Cool, everybody. And to make this even easier for myself, I'm going to divide everything by 4. So I'm going to have 4R squared minus 4R minus 3 is equal to 0. I'm going to continue my working down here so I don't block anything. I now need to factorize this trinomial. I need the factors of 12 that can help me create negative 4. So I'm going to use the factors of 6 and 2. So I'm going to have 4R squared plus 2R minus 6R minus 3 is equal to 0. Then if I group, I'm going to take 2R out as the highest common factor, which is going to leave me with 2R plus 1. Sorry, that looks like a weird one. Let us fix that for all of us. So it's going to be 2R plus 1 minus 3 times 2R plus 1. So the factorized form will be 2R plus 1, 2R minus 3. This is the grouping way of solving a trinomial. You can use your calculators to do another way. So this means that R will be equal to negative 1/2, or R will be equal to 3/2. So if I conclude nicely, A is equal to 16, and R is equal to negative 1/2, or R is equal to 3/2. Everyone, what I want you to note is because I have two different options for my R's and the same A, I'm still going to have to do two separate calculations for the sum of the first 10 terms, because each R will be involved in a different series of calculations. So we're going to use the A and the first R, and then the A and the second R in order to determine the sum of the first 10 terms. Please don't only do one, you will lose marks. So please make sure that you use both r's in order to do the sum of the 10 terms. Let's have a look at the board again. So for the first one, I'm going to look at when r is negative 3 over 2 and a is 16. So again, this is looking at one case of the example because I'm using one of the specific r's. Please note that I've substituted in n is equal to 10 because I am summing the first 10 terms. So when r is equal to negative 3 over 2 and a is 16, the sum of the first 10 terms will be equal to 16 times 1 minus negative 3 over 2 to the power of 10. This will all be over 1 minus negative 3 over 2. So we're going to now type this all into our calculator to determine the sum of the first 10 terms. So it's going to be 16 times 1 minus negative 3 over 2 to the power of 10. And this is all going to be over 1 minus negative 3 over 2. So the sum of the first 10 terms when r is equal to negative 3 over 2 is negative 605 over 32. So this is the first sum of the first 10 terms. Just a reminder, please don't stop your calculations at this point. I still need to see what the sum of the first 10 terms will be with my next r. So this is only one part of the question. We're now going to use the next r and the same a. Let's go back to the board. So I'm now going to be doing the calculation when r is a half and when a is 60. Again, I've substituted in n is equal to 10 because I am summing the first 10 terms. So let us substitute it in together. So the sum of the first 10 terms will be equal to 16 times 1 minus a half. I've substituted in a half because that is my ratio that I'm using for this sum to the power of 10. And this is all going to go over 1 minus a half. Again, I'm going to substitute this all into my calculator. So we are going to have 16 times 1 minus a half. So I'm going to put my half in a bracket so it gets raised to the power of 10. So a half to the power of 10 over 1 minus a half. So this sum is equal to 1023 over 32. So the sum of these 10 terms is equal to 1023 over 32. So guys, I hope that you're still with me at this point. So just a reminder or something to look out for when I am solving simultaneous equations and I get multiple options for A's and R's, or if it's arithmetic, A's and D's, please make sure that you answer the whole question using all of the different cases presented to you. All that I'm going to do now is have a look at our concept map just to revise what I've covered with you. Let's look at the board again. So I have looked at geometric series. We know that geometric series involve adding the specific terms of a geometric sequence together. If you've tuned in another time or if you watched earlier this lesson, we know that arithmetic series are adding the terms of an arithmetic sequence together. So we get both arithmetic and geometric series. The main formulas that are focused on this portion of the lesson is the sum of a geometric series, and this is when I have Sn is equal to a 1 minus r to the power of n over 1 minus r, or Sn is equal to a r to the power of n minus 1 over r minus 1. Please make sure that the numerators have brackets next to the a's so that you're multiplying a into those two different expressions. Great, guys. Please make sure that you also know the difference between Sn and Tn. Sn involves the summing of the specific terms together because it is a series. Tn is referring to your sequences, so your term numbers and your term values. Wonderful, everyone. So I hope that everyone has enjoyed the lesson today. I have covered arithmetic series as well as geometric series. If you tuned in a bit later, you might have only seen the geometric, but I hope this has helped, and I hope that the rest of your day goes really well. Thank you.